Hey guys, what's up? I'm back here and I'm back with the next topic from biomolecule, and what this time is it's about lactose, right? So after the sucrose, this is going to be another disaccharide and it's called lactose. About lactose, I would add you one first thing, that it's also called milk sugar. Why? Because it is common in milk. Why? Because it is present in milk. So lactose is the topic, and I will help you understand three basic things about the lactose. First, what are its monosaccharides? Second, how these monosaccharides are linked together, and third, whether lactose is a reducing sugar or not. So these are the three basic things I'll be talking in this very lecture. So this is again going to be very important, very interesting, and trust me, you're definitely going to enjoy. Let's start the lactose here. What lactose is? So the first thing, like I said, lactose is a disaccharide. So lactose is our topic here. Lactose. The first thing I just told you, that it's also called milk sugar. This is also called milk sugar. Right? So this is a milk sugar. Now about the lactose, you know what? The first thing which I think I must tell you, before I come to some other topic about lactose, is that lactose is a disaccharide. Lactose is your disaccharide. Lactose is a disaccharide. How do you come to know? Once when you do the hydrolysis, of lactose, you obtain beta D, just pay attention here, you obtain beta D galactose. So this is another beta D galactose, and along with that you also obtain beta D glucose. Along with that you also obtain beta D glucose. Beta D glucose. So this reaction is enough to tell you that lactose is a dimer. Lactose is a disaccharide where it is, where its monomers are, where its monosaccharides are nothing but galactose and glucose. Now, I need to tell you a little bit about galactose, is that it's a modified form of glucose. So there is so much similarity with the glucose and galactose. What is that similarity? I'm coming to that, but that's going to be later on. Let's concentrate on the sequential part here. So like I said, lactose is a disaccharide. How do you know that? When you do the hydrolysis, you obtain beta D galactose and beta D glucose, right? But when you do the condensation of these two, you will obtain lactose back again. That is also enough to help you understand that lactose is a disaccharide. Second important thing about the lactose is that how it is formed actually. So this is going to be the second important part, its structure, right? Its structure, right? Its structure. The first thing I have to do is I have to draw the beta D glucose here. So what is a glucose? A glucose is a 6-membered ring. A glucose is a 6-membered ring here. You do know. So a glucose is a 6-membered ring where the 6th member is actually oxygen. So you have carbon at these places, right? This is your first carbon. Pay attention. This is your first carbon, and of course you have your 6th carbon right here. Right? And then this is going to be a hydrogen, and like this 1, 2. So this first one is also having, since it's a beta, so OH is going to be up here. OH is up here, H is down here. Second one is having OH down here, H inside the ring. Third one is having H outside but OH inside. Fourth one is again having OH outside and H up here, right? So this is the structure of your beta D glucose. Now before I draw the structure of the beta D galactose, I will tell you galactose is a modified form of glucose where only the fourth carbon configuration is different from that of the glucose. right? So what I will do, I will change the configuration of this particular carbon, 1, 2, 3, 4. So what I will do, I will change the configuration of, this very carbon. I will reverse, or I will, flip this OH and H, in the opposite way, so that you will obtain the galactose. So let me draw the galactose here. So the first thing you have to do, you have to draw the cyclic structure here. So this is your penta 6-membered ring, where this 6th member is oxygen, and then you have some bonds just like the glucose here. Just relax and try to understand. This is not something rocket science you have to face some problem with that. So this is first carbon, just pay attention. This is your first carbon, and this first carbon is again having OH up here, H down here. Second is having OH out and H in here. Third one is having H out here, OH in. Now you are up here at the fourth. Now what you have to do, you have to reverse the position of OH and H. So OH is going to be up here, OH is going to be up here, and this hydrogen is going to be down here. So, and again this is your CH2OH, this is your CH2OH, and this is your hydrogen. So this is the structure of your beta D galactose. Let me write this here, beta D galactose, beta D galactose, and this is your beta D glucose. It's already written up there, but somehow I am again repeating. So beta D glucose, beta D glucose. Okay, so these are the two monomers from which the lactose is made up of. Now the question is, where and how the bond is formed between these two monosaccharides. I tell you what, the bond formation is taking place between the first and fourth of these two monosaccharides, right? So that's going to be the third part, but in order to do that, I have to take the space out here, and only then I'll be able to draw the structure of the lactose. We are moving to the third part here, and that's going to be the formation of the glycosidic bond between these two. So I'm going to talk to you about glycosidic bond formation right here. Glycosidic linkage or bond, whatever suits to you, you can call it. Right? Now, this is going to be easy. And how this is going to be? Just pay attention. The glucose molecule uses its fourth carbon here. I tell you, the glucose is using its fourth carbon, and the galactose is using its first carbon. And there, the bond is, forming as oxide linkage, which also call it glycosidic. So now let's talk how the bond is formed between the galactose and glucose. You do know where and how the bond is formed. It's between the first and fourth. So what we need to do, take out the proton from the galactose and the hydroxide from the glucose. When these two combine together, they result formation of a water molecule. So what I'm going to do, I'm removing this hydrogen from here and OH right from the glucose side. So what will happen here, this will result formation of a bond between the first carbon of the galactose and fourth carbon of the glucose. Let me write here, this is the first carbon, and there the glucose is having its fourth carbon. So this glycosidic bond, this is your glycosidic bond here, glycosidic bond. Right? So this bond is formed between the first carbon of galactose and fourth carbon of the glucose. We have come to the fourth, which is going to be the last part. The first one, how lactose is formed. Second, what are the structure related to that, and how the glycosidic bond is formed. Now it's time to find out whether lactose is reducing sugar or it's non-reducing, right? So if you remember, I tell you what, a lactose is a reducing sugar. First answer is that lactose is a reducing sugar. How can you come to know? Because it has either the hemiacetal structure or it has the hemiketal structure. Let's find out which one is here, right? So pay attention here. What you have to do, just pay attention right here on the first carbon. On the first carbon, pay attention. This first carbon of the glucose, is having a carbon right here. There you have one, ether group. You have one ether group here. This one, and then you have another, a hydrogen, and then you also have a hydroxide. And this is enough, let me tell you, this is going to be enough information to tell you that lactose is also reducing. So I'm writing this information right over here. This is again reducing. This is again reducing. So unlike the sucrose, the lactose is a reducing sugar, because it has ether group, it has hydrogen and it has hydroxide on the same carbon, which is on the phos carbon, and that's how it lets you understand that this is again a reducing sugar, right? So what I would add in the end is that in case you find a bit difficulties, what you have to do, you have to practice, right? You have to practice, because once you practice, it's going to be really easy for you, right? This is not some rocket science. There is no such problem like that. So making the structure again and again and going through the reducing, non-reducing, hemiacetyl, hemiketyl, these are something that help you understanding the organic chemistry, especially that biomolecule. So with this, I would say motivating words, I must wind this here. I would say thanks for watching, take care, and if you like my work, I would request you to do a couple of work which you can do without any expenses. First, you can like my work if you do so. Second, you can share with somebody who needs it, even though they do not, you can share it. Third, you can subscribe it, right? And in case you need any help, you can even text me personally, or you can mail me, or whatever way you wish to come in contact with me, you can do. So thanks for watching, take care and good night.